Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss probability. In this chapter, we have discussed the concepts of exercise 16.3 in the previous class. I hope you have understood the concepts of this exercise. Haven't you, my dear children? Right. Now let us discuss the sums in the exercise 16.3. Are you ready to listen the class, my dear children? Right. In this exercise, some questions will be based on deck of playing cards. Do you know, my dear children? Do you have any idea about deck of 52 playing cards? Right. In the deck of 52 playing cards, there are 26 red cards and 26 black cards. Okay, mention total 52 cards will be there. Out of these 52 cards, 26 red cards will be there and 26 black cards will be there. Okay, my children, right. Out of these 26, 13 diamond cards, in these 26 red cards, 13 diamond cards will be there and 13 heart cards will be there. Okay, my children. Similarly, in the black cards, 13 spade cards will be there and 13 club cards will be there. Okay, Mitchell, these are the symbols: diamond, heart, spade, and club. Okay, my children, right. Now let us take some examples to understand the concepts well. Okay, my children. One card is drawn from a well-shuffled deck of 52 cards. If each outcome is equally likely, calculate the probability that the card will be a diamond, and second, not an ace, third one, a black, and fourth, that is black card means a club or spade. Okay, my children. And fourth one, not a diamond, and fifth one, not a black card. Okay, my children. Understood this question? Right. In the deck of 52 cards, one card is drawn. Understood this random experiment, my children? Now we have to find the probabilities of these 5 events. First event is drawing a diamond card. Second event is drawing a card which is not an ace card. And the third one is drawing a black card. It may be a club card or spade card. Okay, my children. And the fourth one, the card should not be a diamond card. We have to find the probability of an event that drawing a card which is not a diamond card. And the fifth one, the probability of an event of that the drawing of a card from a well shuffled 52 card which is not a black card. Okay, my children, understood all these events? Right. Now come to the solution part. When a card is drawn from a well shuffled deck of 52 cards, the number of possible outcomes is 52. Understood this step, my children? How many cards are there in the deck of 52 cards? 52 cards are there. So how many cards are drawn? Only one card is drawn. So number of possible outcomes is 52. This is nothing but n of s. N of sample space. Number of sample points in the sample space. Okay, my children, understood this step? Right. Now come to the first question. Let A be the event that the card drawn is a diamond. Clearly, the number of elements in the set A is 13. As for number children, how many diamond cards are there? Previously, we had discussed. How many diamond cards are there in the deck of 52 cards? Yes, 13 cards. So, number of cards favorable to the event A is 13. As for number children, right. Therefore, P of A is equal to 13 by 52. Understood this step, children? Here n of A is equal to 32 and n of S, this is 52. So n of A by n of S, 32 by 13 by 52. N of A is 13 and n of S is 52. So n of A by n of S. Okay, my children. Here I did not write that formula. P of A is equal to n of A by n of S. Here n of A is equal to 13 and n of S is equal to 52. Okay, my children. So 13 by 52. By simplifying these two numbers, 13 ones are 13 four times. That is equal to 1 by 4. Understood this step, my children? Right. That is, probability of a diamond card is 1 by 4. Understood this step, my children? This is the probability of getting a diamond card. Okay, my children? Right. Next, to come to the second one. We assume that the event card drawn is an ace, is B. Therefore, card drawn is not an ace. E should be B dash. Okay, my children. Here, what is the event here? Not an ace. So, first let us assume that card drawn is an ace card. That is event B. Then B dash denotes the card drawn is not an ace card. As for my children, if B event B denotes card drawn is an ace card, then B dash denotes the card drawn is not an ace card. Understood this statement, children? Right. We know that P of B dash is equal to 1 minus P of B. That is equal to 1 minus P of B. What is P of B here? 1 by 42. Yes or no, my children? How many ace cards will be there? Yes, 4 ace cards. In each design, diamond, club, heart and spade. Each design, 1 ace card will be there. Totally 4 ace cards. Understood this point, my children? So 4 by 52. Understood this step? Right. That is equal to 1 minus 4 1 times, 4 13 times. So 1 by 13. Understood this step, my children? That is equal to, by simplifying these two numbers, we get 12 by 13. Understood this step, my children? Right. Now come to the third event. Let C denote the event. The card drawn is a black card. Therefore, number of elements in the set C is equal to 26. As for my children, previously we have discussed how many black cards will be there in the deck of 52 cards. Yes, 26. 26 red cards and 26 black cards. Yes or no, children? So number of elements in the set C is equal to 26. Understood this statement, children? Means n of C is equal to 26. Okay, my children, n of C is equal to 26. N of S is equal to 52. N of A is equal to 13. Understood these points, my children? Right. That is, P of C is equal to 26 by 52. Understood this statement, children? 26 by 52. N of C by N of S. N of C is equal to 26. N of S is equal to 52. So 26 by 52. Understood this statement, children? So by simplifying these two numbers, we get 1 by 2. 26 1 times, 26 2 times. Understood this statement, children? Right. Now come to the step. The probability of getting a black card is 1 by 2. Okay, my children, understood this event, third event, getting a black card. The probability of getting a black card is 1 by 2. Okay, my children? Right. Now, come to the fourth event. What is the fourth event? Not a diamond. So, we assume in above, see there, the event A. What is the event A here? The card drawn is a diamond. So, not a diamond means A dash. Event A denotes card drawn is diamond. Then A dash denotes not a diamond. The card drawn is not a diamond. Yes or no, my children? Not A. Okay, my children? Right. Now, P of not A is equal to 1 minus P of A. Yes or no, my children? So 1 minus, what is the value of P of A? 1 by 4. Previously we found 1 by 4. P of A is equal to 1 by 4. So 1 minus 1 by 4. Understood this statement, children? Right. That is equal to, by simplifying these two numbers, we get 3 by 4. Understood this statement, children? Right. Now come to the fifth event. What is the fifth event? Not a black card. Okay, my children. Previously we have found third event. What is the third event? Getting a black card. Yes or no, my children? Here we have to find the probability of an event that the card drawn is not a black card. Means C dash. Yes or no, my children? Not C. Probability of not C. Understood this point, my children? Right. We know that P of not C is equal to 1 minus P of C. That is equal to 1 minus 1 by 2. As I mentioned previously, we have found P of C value in the third event, P of C 1 by 2. So 1 minus 1 by 2. That is equal to 1 by 2. Understood this step, my children? Right. Therefore, probability of not a black card is equal to 1 by 2. Understood this step, my children? Right. Now let us take another example. Okay, my children. A bag contains 9 discs, of which 4 are red, 3 are blue, and 2 are yellow. The discs are similar in shape and size. A disc is drawn at random from the bag. Calculate the probability that it will be red, and second event yellow, third event blue, fourth event not blue, fifth event either red or yellow. Understood this question, my children? Here, how many discs are there? Total 9 discs are there, out of which 4 are red, 3 are blue, and 2 are yellow. And one disc is drawn at random from the bag. We have to calculate the probabilities of these 5 events. What is the first event? The disc should be red. Second event, drawing a yellow disc. Third event, drawing a blue disc. Fourth, drawing a disc which is not blue. And fifth event, the disc drawn is either red or yellow. Understood this question, my children? Right. Now come to the solution part. There are 9 discs in all. So the total number of possible outcomes is 9. Yes or no, my children? This is nothing but n of s, number of sample points in the sample space. Let the events A, B, C be defined as A. The disc drawn is red. Okay, my children, we are defining 3 events, namely A, B, C, such that event A is disc drawn is red. Next event B is the disc drawn is yellow. Okay, my children. And third event event C is disc drawn is blue. Okay, my children, understood this? 3 events, right? Now come to the first part of the question. The number of discs are total 9. Out of this, how many red discs are there? 4 discs. So n of A is equal to 4. This is n of S. This is n of 4. Then can we find P of A? Yes. Hence P of A is equal to n of A by n of S. Okay, my children. What is n of A here? 4 by what is n of S? 9. Okay, my children, 4 by 9. This is the event of the first event, probability of event A. Okay, my children, right. Now come to the second event. The number of yellow discs. How many yellow discs are there? 2. That is n of B is equal to 2. Understood this statement, children? We have written n of B. What is n of s? 9. Then can we find p of b? Yes. Therefore, p of b is equal to n of b by n of s. That is 2 by 9. Understood this step, my children? Right. Now come to the third event. The number of blue discs. How many blue discs are there? 3. That is n of c is equal to 3. Equal to 3. N of s is equal to 9. Then can we find p of c? Right. Therefore, p of c is equal to n of c by n of s. That is equal to 3 by 9. Understood this step, my children? By simplifying these two numbers, we get 1 by 3. This is p of c. Okay, my children? Right. Now come to the fourth event. Clearly, the event not blue is not C. Yes or no, my children? Not blue. The event not blue. This event not blue denotes not C. Yes or no, my children? We have already found P of C. Then can we find P of not C? Yes. We know that P of not C is equal to 1 minus P of C. Yes or no, my children? That is equal to P of not C is equal to 1 minus 1 by 3. By simplifying these two numbers, we get 2 by 3. Understood this probability, my children? Right. Now come to the fifth event. The event either red or yellow may be described by the set A or C. Yes or no, my children? Since A and C are mutually exclusive events, we have, as I mentioned, the events A and C are exclusive events because the event A is a red disk and event C is a blue disk. There is no common, so they are exclusive events. So we have P of A union C, P of A or C, that is equal to P of A union C is equal to P of A plus P of C. Okay, my children, that is equal to, we have already found P of A value and P of C value. Let us substitute that values 4 by 9 plus 1 by 3. By simplifying these two numbers, we get 7 by 9. Understood this example, my children? Right. Now, let us take another example. Two students, Anil and Ashima, appeared in an examination. The probability that Anil will qualify the examination is 0.05 and that Ashima will qualify the examination is 0.10. The probability that both will qualify the examination is 0.02. Find the probability that both Anil and Ashima will not qualify the examination. Okay, my children. And the second event, at least one of them will not qualify the examination. And third event, only one of them will qualify the examination. Understood these events, my children? There are three events. We have to find the probabilities of these three events. What is given? P of here Ashima, Anil and Ashima are attending an examination and the probability of qualifying Anil in the examination is 0.05 and the probability of Ashima qualifying the examination is 0.10 and both will qualify, that is intersection. As I mentioned, both means intersection is given. Okay, my children, these are the given data. Now come to the solution. Let E and F denote the events that Anil and Ashima will qualify the examination respectively. Given that P of E is equal to 0.05, P of F is equal to 0.010 and P of E intersection F is equal to 0.02. Understood this step, my children? We assumed here E and F are the events denoting the Anil and Ashima will qualify the examination. So In the question, what is given? P of E, P of F and P of E intersection F. These are the given data. Okay, my children, understood this one? Right. Then come to the first one. What is the first event? Both Anil and Ashima will not qualify the examination. We have to find the probability of this event. How do you define? How do you denote this event? E dash intersection F dash. E dash means Anil not qualify. Ashima not qualify is denoted by F dash. So both will not qualify. Should not qualify means E dash intersection F dash. Understood this event, my children? Understood this notation? Right. Since E dash is not E, that is Anil will not qualify the examination, and F dash is not F, that is Ashima will not qualify the examination. Yes or no, my children? E not denotes Anil will not qualify the examination. F denotes Ashima will not qualify the examination. Okay, my children? Right. Also, E dash intersection F dash is equal to E union F whole dash by De Morgan laws. Here we use the previous knowledge of set theory. In the set theory, we have learned De Morgan laws. E union F whole dash is equal to E dash intersection F dash. Yes or no, my children? Right. Now, P of E union F is equal to P of E plus P of F minus P of E intersection F. Okay, my children, do you remember this formula? Yes, in the previous class, at the time of concepts, we have discussed this point. P of E or F means P of E union F is equal to P of E plus P of F minus P of E intersection F. Same as in the case of set theory, N of A union B is equal to N of A plus N of B minus N of A intersection B. Here, P of E union F is equal to P of E plus P of F minus P of E intersection F. Okay, my children? Right. So, in this formula, we substitute the values of P of E, P of F and P of E intersection F. Okay, my children? Understood this step? We substituted the three values. By simplifying these three values, what will you get? 0.13. This is the probability of E union F. Okay, my children? But we should find E union F whole dash. Okay, my children? Right. Therefore, P of E dash intersection F dash is equal to P of E union F whole dash. That is equal to 1 minus P of E union F. Yes or no, my children? That is equal to 1 minus 0.13. That is equal to 0.87. Understood this step, my children? Here, P of E dash intersection F dash is equal to P of E union F whole dash. On both sides, we have taken probability. Then we get this step. Understood this step, my children? Right. That is equal to P of A dash means 1 minus P of A. Yes or no, my children? So similarly here P of E union F whole dash means 1 minus P of E union F. Understood this step, my children? That is equal to 1 minus, we substituted the value of P of E union F, 0.13. By simplifying these two numbers, we get 0.87. Understood this step, my children? Right. Now come to the second part. At least one of them will not qualify the examination. This is the probable event. Means 1 minus P of both of them will qualify. Yes or no, my children? Right. Both events denote the same. P of at least one of them will not qualify means 1 minus P of both of them will qualify. Okay, my children? Right. That is equal to 1 minus 0.02. That is equal to 0.98. Understood this step, my children? Right. Now come to the third event, C. Third event, see the event only one of them will qualify the examination is same as the event either Anil will qualify and Ashima will not qualify, or Anil will not qualify and Ashima will qualify. As one mentioned, that is E intersection F dash or E dash intersection F, where E intersection F dash and E dash intersection F are mutually exclusive events. Understood these three lines, my children? Only one of them will qualify the examination means either Anil only will qualify, Ashima will not qualify, or Anil will not qualify and Ashima only will qualify. Then we denote these sentences by E intersection F dash or E dash intersection F. But these two events are mutually exclusive events. Okay, my children? Right. Therefore, P of only one of them will qualify is equal to P of E intersection F dash or E dash intersection F. Understood this step, my children? Right. That is equal to P of E intersection F dash plus P of E dash intersection F. Understood this step, my children? Because these two events are mutually exclusive events. Here in the middle or is given, so we can add the two probabilities separately. We find them and we add them. Okay, my children? Right. That is equal to P of E minus P of E intersection F plus P of F minus P of E intersection F. Okay, my children? E intersection F dash denotes E minus E intersection F. E dash intersection F denotes F minus E intersection F. Understood this step, my children? Right. So in this expression, let us substitute all the four values. Then we get this step. Okay, my children? By substituting all these values and simplifying them, we get finally 0.11. Understood this example, my children? Right. Now let us take another example. A committee of 2 persons is selected from 2 men and 2 women. What is the probability that the committee will have no man? Second event, one man. Third event, 2 men. Understood this question, my children? Here we have to find the probabilities of events selecting a person. That person should not be man. One man. Out of the 2 persons, 1 man. And 2 persons should be men. For these 3 events, we have to find the probabilities. Okay, my children. Selections. Selections means you have to recollect the knowledge of permutations and combinations. Combination means selection of objects. Yes, sir, my children. Permutations means arrangement of objects. So this question relates to combinations. Okay, my children. Right. Come to the solution part. The total number of persons. How many persons are there? 2 men and 2 women. That is total 4 persons are there. Okay, my children. Right. Out of these 4 persons, 2 can be selected in 4C2 ways. Yes, sir, my children. Here 4 objects are there. From these 4 objects, 2 objects should be selected. In how many ways 2 objects can be selected? 4C2 ways. Yes, sir, my children. Do you remember the concept of combinations? Yes. We use that knowledge here. Okay, my children? Right. Now come to the first event. No men in the committee of the 2 men. There will be 2 women in the committee. Yes or no, my children? We are selecting 2 persons. Here no men means that 2 persons should be women. Yes or no, my children? Right. How many women are there? 2 women. So from the 2 women, we have to select 2 men. Both 2 men should be selected. 2 can be selected in 2C2 ways. That is one way. Yes or no, my children? Understood this step? We can select 2 women out of the 2 men in 2C2 ways. That is one way. What is the value of 2C2? One way. 1. Yes or no, my children? Understood this step? Right. Therefore, P of no man is equal to 2C2 by 4C2. This is n of A. This number denotes n of A. This number denotes n of S. Number of sample points in the sample space. Understood this step, my children? Right. That is equal to 1 into 2 into 2 by 4 into 3. Do you remember that combinations, my children? NCR. How do you write NCR? Yes. N factorial by R factorial into n minus R factorial. Use that knowledge here. Okay, my children. Or you can use like this also. NCR. NCR is equal to NCR is equal to, how do you write, how do you find the value of NCR? N by R N by R into N minus 1 by R minus 1 into N minus 2 and so on. Okay, my children. Do you remember this one? NCR formula n by R into n minus 1 by R minus 1 into n minus 2 by R minus 2 and so on. By using this formula, we get this step. Understood this step, my children? Right. That is equal to 1 by 6. By simplifying these numbers, we get finally 1 by 6. Understood this step, my children? Right. Now come to the second event. What is the second event? One man should be selected. Means one man in the committee means there is one woman and one man. Yes or no, my children? Right. So we have to select one man and one woman to form a committee of 2 persons. Yes or no, my children? Right. One man out of 2 can be selected in 2C1 ways and one woman out of 2 can be selected in 2C1 ways. Together, they can be selected 2C1 into 2C1 ways. Yes or no, my children? Understood this step? We have to select one man from the 2 men and one woman from the 2 women. In how many ways? 2C1 ways. Here also we can select in 2C1 ways. So both events should be done. Both operations should be done. So by multiplication theorem, 2C1 into 2C1 ways. Understood this step, my children? Right. Therefore, P of one man is equal to 2C1 into 2C1 by n of S. What is n of S here? 4C2. Okay, my children. Understood this step? That is equal to 2 into 2 by 2 by 2 into 3. By simplifying these numbers, what will you get here? 2 by 3. Understood this step, my children? Right. Now come to the event C. 2 men. 2 men can be selected in 2C2 ways. How many men are there? 2 men. So how many men should be selected? 2 men should be selected. So this can be done in 2C2 ways. Understood this step, my children? Right. Therefore, P of 2 men is equal to 2C2 by 4C2. Here n of s is equal to 4c2. Okay, my children. So by simplifying this number, what will you get here in the numerator? 2c2 values 1 by 4c2. Okay, my children. That is equal to 1 by, what is the value of 4c2? 6. Okay, my children. Understood this example? Right.